Hi, welcome you all for my next video on Module 5, which is on torque measurement, force measurement and pressure measurement, also on the measurement of strain and temperature. In this video, I am going to discuss on the torque measuring instruments. Further, here in the torque measurements, elastic diaphragm force, the measurement of torque is associated with determination of power developed or consumed by the rotating part. That's what we generally call it as torque. The different types of torque dynamometers are being used for the measurement as well as also for the torque and power. The torque, which may be measured in terms of reaction force and arm length or angular twist. The force, in addition to its effect along its line of action, any may exert a turning effect which is relative to any axis other than those intersecting the line of action, and this effect we'll call it as torque. Why it is important, especially to obtain the load information necessary for stress or deflection analysis. Torque is generally associated with determination of mechanical power. There are different types of dynamometers, or the dynamometers can be categorized under three main classes. One is absorption dynamometer. It absorbs the mechanical energy as the torque is measured and hence useful for measuring power or torque used in engines or electric motors. In this type of dynamometers, generally the energy produced by the engine is absorbed by frictional resistance of the brake and finally transformed into heat. Some of the examples for the absorption dynamometers are like Brownie brake dynamometer, which is block type and band type. Second one is about row brake dynamometer, or the third example is hydraulic dynamometer. Fourth one is like eddy current dynamometer. These are some of the examples for the absorption type of dynamometer. Second one is transmission dynamometers. In this dynamometer, these are the passive devices placed at any appropriate location within the machine or in between the machine to sense the torque at that location. Or it is also in this type of dynamometers, the energy is not wasted in friction, but energy is conveyed to the surroundings in a useful mechanical or electric form. Some of the examples for the transmission type of dynamometer is belt transmission dynamometers, epicyclic train dynamometers, torsion dynamometers, strain gauge dynamometers. The third one is like driving dynamometers. These are the type of dynamometers in which used to measure power or torque as well as provide energy to operate devices to be tested, generally pumps and compressors. Here in this type of dynamometer, power producing or observing device whose power to be measured is coupled with electrical generator or electric motor. The motor or generator measure power and also supply energy to operate the tested devices. Further, the type of dynamometer is employed with the pumps and compressor for determining their performances. Some of the examples is like electric cradle dynamometer. First one, let us go with the torch. So let us discuss on the dynamometers. First one is of Brownian brake type of mechanical dynamometers. These dynamometers are of absorption type. These are the most simplest and commonly used type of dynamometer. The figure which you can see represents the Prony brake dynamometer. In this you can see the two wooden blocks are mounted on either sides of a flywheel. Rope is connected. One side it is completely tightened with the help of tightening arrangement, and further there is a lever arm. The other end of the lever arm is connected to the force F at a distance of say L. So let us go in detail about the points of this construction. Here two wooden blocks are mounted diametrically opposite on a flywheel attached to the rotating shaft whose power to be measured. One block carries a lever arm and an arrangement is provided to tighten the rope which is connected to the arm. The rope is tightened so as to increase the frictional resistance between the blocks and the flywheel so that the torque exerted by the Prony brake is given by T is equal to F into L, where the force F is measured by the conventional force measuring instruments like balances or load cells, and the power dissipated in the brake is calculated by using the following equation. P is equal to 2 pi nt by 60, or in terms of T in terms of FL. On substitution we can rewrite the equation as 2 pi FLN divided by 60. It is in terms of watts. If it is in terms of kilowatts, we have to divide it by 60. So the Prony brake is an inexpensive, but it is difficult to adjust and maintain a specific load. So let us go to the limitations. The Prony brake is inherently unstable. Its capacity is limited by the following factors. Something like the first one, it is due to wear of the wooden blocks. The coefficient of friction varies between the blocks and the flywheel. Further, it requires continuous tightening of the clamps. Therefore, system becomes unsuitable for the measurement of large powers. Further, the use of Prony brake results in excessive temperature rise, which results in the coefficient of friction, a decrease in the coefficient of friction, leading to failure of brakes. So in order to limit the temperature rise, cooling is required continuously. This is done by running the water into the hollow channel of the flywheel. When the machine torque is not constant, the measuring arrangement is subjected to oscillations. So there may be a changes in the coefficient of friction, and hence the reading of force may be difficult to take. Advantages: it is simple in construction and very less costlier. They are suitable for the measurement of small power. Disadvantages: coefficient of friction is reduced due to the wear out of block. Hence, in the long run, dynamometers become unserviceable for the measurement of large powers. Due to heat generation, temperature rises, resulting decrease in coefficient of friction. Hence, cooling system is required. When the driving force on the shaft is not uniform, this type of dynamometer is subjected to severe oscillations. Next, we move to the hydraulic dynamometers, or we call it as a fluid friction dynamometers. Here, it is a most simplest form of which acts as a water vapor, in which water itself acts like a brake kind of system, or water simplest form which acts as a water brake. The capacity of hydraulic dynamometer is a function of two factors here. One is the speed and the second one is the water level. This the diagram in that you can see there are a number of components which are involved in the hydraulic dynamometers. One is the housing, which houses the radial blades inlet of water, and then it is connected to a reaction arm and the force measuring device. Further, it is mounted on a true union bearings and a shaft, and then the housing also involves houses the water reservoir in which the blade is rotating, and then the water is connected to the output to maintain the different levels of water for the based on the amount of friction being required. Now this is a power regarding the hydraulic dynamometers. This is a power sink which uses the fluid friction for the dissipation of the input energy, so that we can measure the input torque or power. The capacity of hydraulic dynamometer is always a function of two factors. As I mentioned, one is speed and the water level. The power consumed in friction cube of speed is approximately. The torque is measured with the help of the reaction arm. The power absorption at a given speed may be controlled by the adjustment of water level in the housings. This type of dynamometer may be made in considerably larger capacities than the simple Brownie brake, because the heat generated can be easily removed by circulating the water into and out of the housings. True union bearings of the dynamometer housing, allowing it a freedom to rotate except for restraint imposed by the reaction arm. In this dynamometer, generally the power absorbing element is the housing, which tends to rotate with the input shaft of the driving machine. But such rotation is constrained by the force measuring devices, such as some of the scales or load cell placed at the end of the reaction arm of radius r. By measuring the force at the known radius, the torque T may be computed by the simple relation. The advantages of hydraulic dynamometers over mechanical brake type of dynamometers are: hydraulic dynamometers constantly supply of water running through the brake medium act as a coolant, whereas the brake power of very large and high-speed engines can be measured. The hydraulic dynamometers may be protected from hunting effects by means of dashboard dampers. In hydraulic dynamometers, there is a flexibility in controlling the operation. So these are some of the advantages of hydraulic dynamometers over mechanical dynamometers. So these two are some simple examples of torque measuring instruments. There are few more, like in the mechanical dynamometer itself, like there is a rope brake dynamometer, which consists of one or more ropes around the rim of a pulley of flywheel, which is keyed to the shaft of an engine, and the upper end of the rope is connected to a spring balance, whereas lower end connected to a dead weight. And to avoid the slipping of the rope over a pulley, 3 or 4 U-shaped wooden blocks are placed at equal intervals around the circumference of the pulley. Due to friction between the rope and the drum, A high amount of heat is generated and hence the pulley is provided with internal flanges on the rim. It forms a channel for the flow of water to cool the pulley and the drum. And even the rope brake dynamometers are commonly used for the absorption of wider range of powers. And the rope brake dynamometer is also most simple in construction. Further, it is most suitable than the Brownie brake dynamometer, and hence it can be used for wide range of powers. It can also be used for long test with little overheating and without requiring adjustment. The disadvantages are being very less accuracy because of change of coefficient of friction of the rope with the temperature. Cooling system is required for the rope brake dynamometer, and since it is also a mechanical type, a high friction is being involved there. So over the mechanical and electrical type, there is hydraulic type, there is electric dynamometers. They are actually an electric generators which generates an electric current when driven by an engine undergoing the test. The current developed may be absorbed through suitable resistance or may be used for lighting and other purposes. The output produced by the generator is known in the form of electric horsepower and is always less than the horsepower of the engine that drives it due to friction in the generator and other losses. Knowing the efficiency of the generator, the electric horsepower of the generator can readily be converted into the actual brake horsepower developed by the engines. Generally, electric dynamometers can be classified as eddy current dynamometers, DC current dynamometers, DC dynamometers, DC motors and generators, AC motors and generators. The working principle of eddy current is like it consists of a stator on which are fitted a number of electromagnets and a rotor disc made of copper or steel and coupled to the output shaft of the engine. When the rotor rotates, eddy currents are produced in the stator and due to magnetic flux set up by the passage of field current in the electromagnets, and these eddy currents are dissipated in producing heat, so that this type of dynamometer requires some cooling arrangement. The torque is measured exactly in other types of absorption dynamometers. The load in internal combustion engine testing is controlled by regulating the current in the electromagnets. Some of the advantages of eddy current dynamometers are like high brake power per unit weight of dynamometer is required. Is there? They offer high ratio of constant power speed range up to 5:1. Level of field excitation is below 1% of total power being handled by the dynamometers. Thus, they are easy to control and operate. Development of eddy current is smooth, hence torque is also smooth and continuous under all conditions. They are relatively higher torque under low speed conditions. Further, it has no intricate rotating parts except shaft bearing. No natural limit to size, either small or large. Disadvantages: they are very susceptible to magnetic permeability changes. The only effect on conductive materials, not suitable for large areas and are complex geometries. No permanent record or unless automated. Signal interpretation is required. DC dynamometers, they are most versatile and accurate dynamometers in the cradle DC dynamometer. It is usable both as absorption as well as transmission type of dynamometers. Hence, it is most widely used for power and torque measurements on IC engines, small steam turbines, pumps, etc. Generally, a DC motor is basically a DC dynamometer is basically a DC motor with a provision to run it as a DC generator, whereas the input mechanical energy on conversion to electrical energy can either be dissipated through a resistance grid or recovered for the use. When used as absorption dynamometers, it performs like a DC generator. Cradling in true union bearings permits the determination of reaction torque, and the torque is measured by measuring a balance force at a fixed known moment arm exciting from the body of the dynamometers. When used as transmission dynamometers, it performs as a DC motor. It then measures the torque and power input to the machine, example, a pump that absorbs the energy. The two good features of the DC dynamometers are its good performance at low speeds and ease of control. It can be either adjusted to provide from 0 to the so-called base speed. Commercial dynamometers are required with control for precise variation of the load and the speed of the machine. The major advantages are being like they are fast, responsive, not coolant required as it is air cooled, and line generative. So some of the disadvantages are being like they are costlier, they needs high amperage electrical service, high inertia or resistance. So these are some of the different types of dynamometers which are used for measurement of torque or power. If we compare the electric dynamometers among themselves, eddy currents are precise control, low maintenance and widely accepted in automotive industries, whereas it poses the disadvantages like high inertia and moderate cost. Whereas AC type of dynamometers are motors and absorbs very low inertia. They are very fast response and line generative. Whereas disadvantages are like their high cost, requires high amperage and electrical service. Whereas the DC type of electric dynamometers are motors and absorbs the energy. Their fast response, low speed, no coolant is required in DC motors. They are line generative, whereas the disadvantages are like the high cost dynamometers and power amplification system. They are high inertia and requires high amperage electric service. That is how we can compare the electric dynamometers among themselves. So this video we will stop here with the torque measurement and power measurement devices. In the next video, I will discuss on the pressure measuring devices. I hope it is clear to lot of the things about this torque measuring devices. If you have got any doubt, please post the query or mail the query to my email ID. I will try to answer those queries. I have used different resources and textbooks as well as internet resources. I acknowledge all such sources which are being used as a part of this teaching in preparation of this teaching material. I acknowledge and also thank to those sources, and I don't claim any kind of novelty in that. Further, I thank to all uh, and also I thank you for watching this video. Hope things are clear. We will meet you again in the next video. So thank you. Bye.